Let's review load instruction and store instruction. So in ARM, we have load instruction, LDR. We're going to load content of memory into register. So that's what we call load register. Again, this is from memory to register. From memory to register. And for the store, we're reading from register to memory. So we're storing the content of register into memory. That's the major difference between LDR and STR. Back to LDR. When we have LDR R0, R1, comma, number 12, this is the decimal number 12. So we need to read the content of R1. R1 we are just making up 10. That means that is number 16. R1 plus number 12. That is R1 is number 16 plus number 12. That is number 28. So we need to go into memory and just use the decimal number, memory location 28. And let's say we have OXABC. Then read this content of the memory and bring it to where? R0. So after this, we're going to have R0 equals to 0xabc. So here's the example, and if the C code is given as A equals to mem2, that means we need to go to memory array number 2. Remember, very first one is 0. This is array 0, array 1, array 2, and so on in the C code. When you convert this into ARM assembly code, this array 2 memory address of 8. Why? Because it's a byte addressing and we're using big endian. Therefore, the address is always go up by 4. So 0, 4, 8, 12, 16, and so on. R5 is 0, 0 plus 8, which is array number 2. And when we bring this content to register, we need to bring as a block, whole block. We're going to talk about this block in chapter 8. But when we bring something from the memory to register, we need to bring as a block. Store, we said we're going to go from register to memory. So we need to read R9, we said this is the register, even though we call it RD, this is actually source register. So we need to read the content of R and store into memory where memory location of this is the address. Now, why this is 14? Because we need to go array number 5. 5 times 4, that is 20. This is the decimal number. Convert this decimal number into hex. Hex is a 16 base. It's more than 16, so we can subtract 16 and the remainder of 4. That means OX1 and 4. In this example, we have R9 as a 42, which is in hexadecimal as 2A. Right now, R9 has OX2A. We're going to put it into memory location where 0 plus OX14, that is decimal number 20. So in decimal number 20, we are going to have OX2A. It was something else. However, after we execute this STR instruction, it's going to be new content of memory.